right. Well, thanks everybody for being here. I think we're at a really interesting point right now with AI. Most organizations have moved past experimentation, and AI is starting to become infrastructure. It's getting connected to content systems, knowledge systems, customer data, internal workflows, support operations, search, analytics, and increasingly, decision making. While organizations are racing to adopt AI, I think it's a much more important question is getting far less attention. Who controls the data? Who owns the data? Because once AI becomes infrastructure, data governance stops being theoretical and it becomes operational. And this is really what I'm here to talk about today. In this deck, some slides are decorative. Those that aren't, I'll describe in my narrative. For those of you that don't know me, my name's Matthew Saunders. I'm a white male. I'm wearing an Amazy AI t-shirt with a sport jacket on top, have gray hair and a gray beard. Work at Amazy AI as their AI ambassador. And I've been working in open source since 1999, Drupal since 2006. And I started working with AI at Pfizer in mid-2022. And then about 18 months ago, started messing around with Drupal AI pretty significantly, and then joined the Amazy team about 6 months after that. I spend a lot of time working at the intersection of open source, governance, infrastructure, and now AI. And one of the phrases that I picked up from Michael Schmidt, my boss, is open source maximalist. And I really, really like the idea behind that. And what we mean by that is pretty simple. I generally believe that open systems create healthier, long-term ecosystems than closed ones. I want there to be more portability, transparency, and accountability, and I want less lock-in. And I think AI is forcing us to seriously revisit those concepts. So I think right now, organizations are in what I call the AI honeymoon phase. When people fall in love, they tend to ignore risk, they overshare and trust too quickly, they assume consequences will work themselves out later, and sometimes this is okay. In the microcosm of your own life, personal life, you're making decisions just for yourself. But organizations are behaving exactly the same way with AI right now. So what do I mean about that? Well, contracts are getting uploaded, source code is getting pasted into public tools, customer information, internal strategy documents, and financials are being plopped into ChatGPT. And this is happening sometimes intentionally and sometimes accidentally. Most often through what security teams now call shadow AI. Employees are using unsanctioned AI tools outside official governance processes. And the problem is that most organizations still think they're experimenting with AI. But the reality is that employees have already operationalized it quietly. And once that starts happening, questions around privacy, sovereignty, compliance, and governance become really quickly. And the honeymoon ends. That's usually the moment where organizations start asking things like, where did our data actually go? Who processed it? Which jurisdiction touched it? Was it retained? Was it used for training? And did we even understand the terms we agreed to? So this talk is about what comes next. What happens when the honeymoon is over? How do we build a relationship with AI that you actually can control? There are real-world examples of organizations losing control of sensitive data, sensitive information through AI systems, and it can be expensive. A study by IBM in 2025 showed that 20% of organizations have suffered a shadow AI breach. On average, this costs $670,000 more than traditional incidences. And a whopping 77% of employees have reported pasting company data into generative AI tools. Thales Data Threat Report in 2025 reported that 69% of organizations cite AI-powered data leaks as a top concern. So we already have real-world examples of organizations losing control of sensitive data. The Samsung incident became one of the better-known examples. Engineers pasted sensitive source code into an unauthorized AI tool trying to accelerate development work, which honestly isn't surprising, right? Developers tend to optimize for speed, and if organizations don't provide sanctioned tooling, people will route around that restriction. That's the definition of shadow AI. We're not talking about malicious employees, but employees trying to get their jobs done faster. But once data enters systems outside of organizational control, governance becomes extremely difficult. And this is happening at scale now. We're seeing rising numbers of organizations reporting AI-related data exposure incidents, prompt injection attacks, unauthorized data movement, and compliance concern tied directly to generative AI adoption. And one of the most important shifts that's happening right now is this. AI risk is no longer primarily model risk. It's becoming operational risk. So you've probably heard of the term RTFM, right? Yeah? Hands up if you have. Yeah? I'm being a little bit less rude about it in this. But basically, someone is messing around with the system and asks questions that should be obvious. And at some point, somebody will say, "Well, did you read the flippin' manual?" Almost nobody does. You mess around with the system until you understand what you need to understand about it. Sometimes you ask questions. Sometimes you post on a Reddit thread or on a forum. Most organizations are agreeing to these platforms voluntarily, but no one reads because they're under deadline pressure. So tools tend to be adopted faster than governance teams can react. However, I think it's probably even more important to read the flippin' privacy policy. Because most organizations still do not understand where prompts are processed, where data is stored, which sub-processors are involved, how retention works, or what rights vendors reserve around training and telemetry. Even when organizations do read the policies carefully, there's another issue. Policies are not architecture. A policy is a promise. Architecture is enforcement, and they are not the same thing. I'm not going to walk through this table line by line, but what I want to talk through is the pattern. There are large policy surface areas, which include broad language around processing. The subprocessor chains are large and not well described. Residency guarantees outside specific enterprise configurations are extremely limited. Worse, policies can evolve over time. Now, I don't want to come across as an anti-OpenAI talk or as an anti-Anthropic talk. These companies are operating the way large-scale cloud platforms traditionally operate. The problem is that many organizations are now sending extremely sensitive operational data into those environments without fully understanding the governance implications, especially through unmanaged employee usage. And that gap between usage and governance is where a lot of organizational risk lies now. For a lot of organizations, AI architecture looks a little bit like this. Data flowing outward into systems that they do not control. There's limited visibility and auditability, and there's little or no isolation. And often, very little understanding internally about where the data is actually moving once prompts leave the organization. What organizations are increasingly asking for instead is controlled architecture. AI systems where governance exists in the infrastructure layer, more like this. There's a need for clear regional boundaries where your data is stored and processed, It's becoming critical that we have clear operational controls where there's auditability, isolation, and flexibility around model providers. We need the ability to evolve architecture without rebuilding everything every time the AI landscape changes. In other words, organizations are starting to realize they do not just need AI capability, they need AI governance capability. And all of this shouldn't require an organization to contract with multiple companies, and it shouldn't be so expensive that only enterprise can afford it. Again, I want to be really careful here not to frame this as big AI companies are evil, because I don't believe they are. But that's not really the point. The point is that most public AI platforms were designed first around scale and convenience, and not around customer-specific sovereignty requirements. There's a tension between those different architectural priorities. So, often, hosting is listed as worldwide or left blank. There are no guarantees on and in which country processes your prompts. You end up with long processor changes where perhaps more than 10 third parties could touch your data. And these are mostly US based, which means the Cloud Act applies. Does everybody know what the Cloud Act is? Put up your hand if you do. Just a few people. Okay, it's pretty scary actually. It means that US authorities may be able to require access to customer data. You could be opted into a training by default because consumer data plans data is often used for model training unless you explicitly disable it. And most employees in the free tiers never change that setting. So you're stuck with policy-based, not architecture-based privacy, with no per-customer isolation, no self-hosting, no audit trail. You're left to trust a legal document, not technical architecture. For many organizations, especially in government, healthcare, finance, education, or regulated industries, governance requirements are becoming stricter, not looser, which means concerns around residency, those sub-processors, retention, auditability, and regional control are becoming operational questions now. The key distinction I want to make is this. Privacy policies are important, but infrastructure boundaries matter more because they bind privacy holistically. Organizations are increasingly looking for systems where privacy is enforced technically, not just contractually. Okay, when I talk about AI sovereignty, I usually break it into three pillars: data sovereignty, model sovereignty, and operational sovereignty. Data sovereignty is the one that people think about first. Where's the data processed? Which jurisdiction controls it? Does it cross borders? Is it retained? Can you isolate it regionally? More and more organizations want clear answers to those questions. And if you can't answer those questions, the door slams shut. But data sovereignty alone isn't enough. There's also model sovereignty. One of the biggest risks that organizations are creating right now is hard dependency on single model vendor. AI is moving too fast for that, and organizations need flexibility to switch models, compare providers, adapt pricing, and respond to regulatory changes. Sometimes a move between commercial and open weight models is necessary. And can you do that without rewriting your entire application stack? Finally, there's operational sovereignty, perhaps the most pernicious pillar of all. It is the part that people underestimate the most. Operational sovereignty is about control over your environment itself. Is there flexibility where and how you deploy? Can you set up robust audit trails? Can you control access effectively? Do you have robust governance processes? Who owns or controls your data? Who owns or controls your infrastructure? Can you run AI in ways that align with organizational policy instead of vendor defaults? Is the trust layer deep enough to support ISO 2001, SOC 2, GDPR compliance, and HIPAA? Ultimately, AI governance is not about the model. It's about the surrounding operational system. Part of the reason this conversation is accelerating is because regulation is accelerating. Governments are starting to recognize that AI systems are not just productivity tools. They're becoming part of critical operational infrastructure. The EU AI Act is probably the clearest example of this shift. We're seeing increasing emphasis around transparency, risk management, human oversight, auditability, and accountability. We're also seeing growing concern around cross-border data exposure, especially when sensitive information moves into jurisdictions the organization does not fully control. And even outside formal regulation, many enterprises are now being pushed by legal, compliance, procurement, and security teams to demonstrate stronger governance around AI systems. GDPR enforcement is escalating, with a recent fine of 530 million euros on TikTok for transferring EEA user data to China. California is expanding its AI privacy bills and data broker disclosure requirements. And the US Cloud Act's risk profile has 23% of Canadian organizations migrating away from US headquartered cloud providers. 1 in 3 organizations experienced data sovereignty since last year. I think this is important because it changes our conversations. AI sovereignty stops being an infrastructure discussion and starts becoming an organizational governance requirement. So, what does this actually look like in practice? Usually it starts with introducing control layers between users and model providers. One common pattern emerging is private LLM proxies. These systems are systems that normalize APIs, manage authentication, enforce policy, monitor usage, and abstract model providers away from the application logic. That abstraction layer becomes extremely important operationally because it allows organizations to change providers without rewriting everything upstream. We're also seeing growing use of region-locked deployments to ensure regional processing, regional vector databases, per customer isolation, dedicated storage boundaries, and increasingly, governance controls around what content can even enter AI systems in the first place. Another major area is guardrails, which include prompt injection filtering, input-output controls, policy enforcement, retrieval constraints. As AI becomes more integrated into operational systems, governance increasingly needs to exist at runtime, not just at procurement time. And importantly, none of this requires abandoning AI capability, but it does require us to architect AI systems more thoughtfully. One of the reasons that open source ecosystems matter so much in this conversation is because sovereignty is extremely difficult to achieve in closed systems. If organizations cannot inspect the stack, can't move the stack, can't adapt the stack, can't replace components, then governance becomes dependent on vendor policy instead of organizational control. Open systems change that dynamic. Light LLM Proxy provides API normalization across LLM providers, vector DBs for semantic search, and a little pitch here, Mazy's Drupal AI provider integration is the only Drupal AI provider that bundles LLMs and vector databases into one package with privacy and sovereignty. It provides that with Search API integration for granular content indexing control, and has a single click install with zero learning curve. It all just kind of works together. But in this architecture, Drupal becomes much more than a CMS. It becomes an orchestration and governance layer sitting around AI capabilities, because Drupal is so good at structured content, structured permissions, workflows, search integration, access control, auditability, and policy enforcement. Then underneath that, organizations can introduce abstraction layers like those LLM proxies, the vector databases, regional infrastructure controls, and model routing. The important part is not specific vendor combination. The important part is that the architecture remains portable, composable, and inspectable. Organizations should retain the ability to evolve the system over time instead of becoming permanently attached to the single AI provider. And I think this is where open source has a huge strategic advantage right now. Open ecosystems are naturally better aligned for interoperability and governance than closed ecosystems are. So, if I had to reduce all of this down into a few practical takeaways, they would probably be these. First, if you're evaluating AI architecture, governance needs to be part of the design conversation from the beginning. Please do not add it later after the adoption is already widespread. Questions around residency, isolation, logging, portability, retention, and auditability are becoming foundational questions right now. Second, shadow AI is usually a systems problem, not a people problem. Employees adopt unsanctioned tools when sanctioned tools do not exist. This means organizations need to provide governed alternatives instead of assuming prohibition will work. And third, open architecture matters. The ability to move systems, swap providers, inspect infrastructure, and retain operational control is becoming strategically important very quickly. This is especially true as AI becomes more deeply integrated into organizational operations. And Amazy has helped solve some of these problems with that provider module that I talked about a little bit ago. I think we're moving into a period where organizations will increasingly realize that the real competitive advantage is probably not access to models. Models are becoming commodities. The real advantage is trustworthy operational integration, which provides isolation by default to reduce risk, governance tools by default, complete control over your data, an open stack that's portable and composable, and the ability to evolve over time. That's what AI sovereignty is really about. Thank you, everybody. Really appreciate you spending some time with me today. Hopefully this gives you a useful framework for thinking about AI governance a little bit differently. And if you want to connect with me, that QR code is for LinkedIn. And I think I might have maybe 2 minutes for questions. Yeah. Okay. Yep.
Regions. I can speak up.
Okay.
You mentioned about regions, right? That it's important that your data is being processed. Can you hear me now? Can you hear me now?
Yeah.
Yeah. So you were talking about regions, right?
Yeah.
It's important that data is processed in a specific region. Let's say for U.S. citizens, we want the data to process in the U.S. Data centers. How do you control that?
Yeah. So in the case of the work that we're doing in my company, we have data centers that are set up in individual countries all over the world. So we can guarantee when you choose a region that the data is retained in that region and is processed in that region. If you're doing it on your own, you can actually do this through AWS Bedrock. It allows you to choose the country in which you want your data center to exist, and allows you to do that data processing within that region. Yeah.
But you would still be exposed to Cloud Act, right?
Say that.
You would still be exposed to Cloud Act in that case.
Yes. However, there are other data center providers in the EU, for example, that just aren't as well known. Yeah. And in our case, our parent company is a Swiss company, which isn't controlled by the Cloud Act. Yeah. Any other questions?
It seems like a tension right now is that model development is so rapid that the capabilities of the latest model from the big provider just blows away everything else. I remember when iPhones were new, it doesn't matter if your company was on BlackBerry, the CEO still found a way to get an iPhone.
Yeah.
So I mean, is there a tension here between like the capabilities and just a vast gap between maybe what's available in the system that we want versus the ones that we do?
Yeah, so that's super interesting, and actually there's a sort of add-on to that. So in certain regions, you can't actually use certain models for a variety of reasons, which is really, really frustrating. So it turns out that the largest number of models that you can access in a region is the U.S. But when you go to other countries, the available models actually decreases significantly. One of the things that I think is super useful about what we've done is that when you use our service, you've got access to the maximum number of models available in that region, so you can experiment, right? So if you want to play around with Sonnet, and then you say, you know what, this model is actually not well tuned for the things that I'm doing. I actually want to use Haiku instead for this particular thing, and I want to use Kimi for this particular thing, and so on. You're in a position where you can shift models and go through model routing like I was talking about earlier, so you can get to hopefully the best cost profile and also the best model that's usable. All right. Well, thank you again, everybody. Appreciate your time.